Because the inverses of radical functions, these integer power functions, work out really nicely. They give us polynomials that we can just simplify. We can solve equations in which we have two or more radical terms. To do that, we'll just choose one radical to isolate and eliminate. And then as we work things out, we will end up with something that contains only one radical. We'll isolate and eliminate that, and we'll end up with a polynomial equation. In theory, we could do this with any number of radical terms, but in practice, at 3, 4, 5, 6 radical terms, the algebra gets really unwieldy, and we're going to start to look around and see if there's a trick that we could use to make it easier. But with two radical terms, it's still relatively straightforward. So we can actually solve equations like that in practice. So let's see an example where we have an equation with two radical terms. So this equation has two radical terms. And the first thing we're going to need to do after we copy this is to arrange things so that one of my radical terms is alone on one side of the equation. So to do that, I'm going to add square root of x plus 4 on both sides. On the left, I'll just be left with the square root of 2x plus 1. On the right, I'll have 1 plus the square root of x plus 4. And now this radical term is isolated. If I square this, it'll cancel out the square root, and I'll just be left with 2x plus 1. So rather than think of this step as rewriting in terms of the power function, I'm going to think of this step as applying the power function to both sides, because the two radicals make it a little bit unwieldy otherwise. So square root of 2x plus 1 all squared. I've got 2x plus 1. Right? The squared undoes the square root. On the right, I'm squaring something with two terms. So remember our perfect square binomials. A plus b squared, that's a squared plus 2ab plus b squared. We'll have 1 squared plus 2 times 1 times the square root of x plus 4 plus the square root of x plus 4 squared. So 2x plus 1 equals 1 plus 2 root x plus 4 plus x plus 4. 2x plus 1 equals, and then we'll combine like terms on the right. 2 root x plus 4 plus only one x term on the right. 1 plus 4 is 5 on the right. And now we want to get 2 times the square root of x plus 4 by itself. So we'll subtract x on both sides. We'll subtract 5 on both sides. We've got x, right? 2x minus x is x. 1 minus 5 is negative 4. And then on the right, we'll have 2 times the square root x plus 4. Now, we could at this point divide both sides by 2 to fully isolate this radical. But, we have this power of a product rule. If I have the product of two things and I square it, that just squares each of the numbers I'm multiplying. I think I'd rather deal with that than deal with the fractions I would get if I divide both sides by 2. So I'm going to say x minus 4 squared is 2 root x plus 4 squared. On the left, I'm squaring something with subtraction in it, so that's a binomial. I'll have x squared minus 2 times 4 times x plus 4 squared. On the right, I'll have 2 squared times the square root x plus 4 squared. So working all this out, on the left I've got x squared minus 8x plus 16. On the right, I've got 4 times x plus 4. And now I have what I hoped to have, an equation with no radicals in it. I can finish solving. First, I'll multiply out on the right. X squared minus 8x plus 16 is 4x plus 16. Now, this is a polynomial equation. I want to get 0 on one side. I'll subtract 4x on both sides. So 8x minus 4x is negative 12x. 16 minus 16, that's 0. This gives me something really easy to factor. Right, I'll factor out a common x. I've got just x times x minus 12 equals 0. So one of these two factors has to be 0. Either x is 0 or x minus 12 is 0, which means x is 12. Two possible solutions, x is 0 or x is 12. Let's see how those work in the original equation. If x is 0, on the left, we have the square root 2 times 0 plus 1 minus the square root of 0 plus 4. So that's the square root of 1 minus the square root of 4. That's 1 minus 2 is negative 1, which is not 1. So 0 is not a solution. On the other hand, when x is 12, we have the square root 2 times 12 plus 1 minus the square root 12 plus 4. That's the square root 25 minus the square root 16. So that's 5 minus 4, which does equal 1. Only x equals 12 is actually a solution. And notice, this number is the opposite of what I wanted to see. X equals 12 is a solution. X equals 0 was an extraneous solution. Since we took even powers to eliminate the roots, we had to check for extraneous solutions. And in fact, we found one and threw it away.